In this video, we're gonna talk about continuity on an interval. So let us first recall what is an interval. So there are three types of interval. So if you have the interval like this, AB, this is called open interval. So open interval. Open interval means that the endpoints of the interval are not included in the set. Say for example, if we have open interval AB, the endpoints A and B are not included. Okay? If we're going to draw the number line, we have that A, this is B. So all the numbers only between A and B. So we are going to put a hole dun sa A and B. So the values are only this portion. Okay? That's for the open interval. We have closed interval, which is denoted by this symbol or notation. So for open interval, we use parentheses. For closed interval, we use brackets. Okay? So this is closed interval. So the difference between open and closed interval is that the endpoints of the interval are included in the set. Okay, say for example, if we have this one number line, A, B, so we include A and B. So that's why we have a shaded here. So yan, all the values between A and B included A and B, inclusive. Okay, we have another one. We have like this one bracket and one parenthesis, or pwedeng ganito. So this is called half open interval. Okay, so in half open interval, one endpoint is included but the other one is not included. Okay, so these are the three types of interval that we're going to consider in continuity of a function on an interval. Okay, so let us talk about how to determine whether a function is continuous on a given interval. Okay, let's say we have a function f of x equals x cubed minus 2x squared plus 1. So what are the intervals for which this function is continuous? The easiest way to do this is to find first the domain. Okay? Because when the domain is the set of all real numbers, this means that the function is continuous in all interval. Okay? So in this example, the given function is a polynomial function. And we know by definition that a polynomial function is defined for all real numbers. So the domain of this function is the set of all real numbers, or from negative infinity to positive infinity. What does this mean? This means that the given function is continuous in any interval. Okay? Continuous everywhere siya. Kasi this is a polynomial function. Okay? How about the next one? We have f of x equals x over x squared plus 4. Okay, take note of this because this is a rational function. Okay, we know that a rational function is defined only for all values of x that will not make the denominator equal to 0. But look at the denominator. We have x squared plus 4. Is there any value of x that will make this denominator 0? Look at this one. This is addition. So, and we know that when we raise a number to 2, whether it is positive or negative, the result is always positive. So when you add a positive to positive, the result is positive numbers. Okay? It can never be 0. Therefore, even though this is a rational, its domain is still the set of all real numbers because there's no value of x that will make the denominator 0. In short, the given function is defined for any interval, or rather, the given function is continuous for any interval. Okay, let's have this one. How about this? Let's say f of x equals x over x minus 1. Okay, this is a rational function, right? So look at the denominator. Is there any value of x that can make the denominator equal to 0? So by looking at the denominator, we have x minus 1. We try to equate it to 0 and solve for x. So that's positive 1. So the value of x that will make the denominator 0 is 1, right? Because 1 minus 1, 0. So its domain will be all real numbers except 1, or in interval notation, from negative infinity to 1 in union with 1 to positive infinity. So what does this mean? The given function is continuous on any interval except those intervals that include 1. Okay? So, i-continuous siya sa lahat ng interval except yung interval na meron si 1. So, halimbawa, so these are intervals for which the function is continuous. So, ito yung mga intervals kung saan continuous siya. Example, 0, 1. Interval 0, 1. Although you can see in the interval the number 1, but it is clear here that 1 is not included because this is an open interval. Since 1 is not included in this interval, the given function is continuous. Let's say we have 1 to positive infinity. So continuous also because 1 is still not included in the interval. Negative infinity to 1. Also continuous because 1 is not included. Let's say negative 5 to negative to 1. Let's say 1. Half open. So still continuous siya. Although half open to, we include negative 5 but 1 is not included. So still continuous siya. Let's say 2 to 10. So this is a closed interval but still the function is continuous because the value 1 is not included or not belong to this interval. 2 is to the left of 1. 1 is to the left of 2 rather. So, still continuous. So, ano yung mga functions or intervals rather na discontinuous siya? Okay, syempre, first natin, the closed interval 0, 1. So, discontinuous siya because 1 is included in the interval. Say, negative 1 to 5. Open interval, negative 1 to 5. So, discontinuous siya because 1 is between negative 1 and 5. So, 1 is belong to that interval. Say, negative infinity to 1. Okay, this one. So, discontinuous because 1 is included. Negative 2 to 2. So, 1 is between negative 2 to 2. So, still discontinuous yung given na function. Okay? So, let's try another example. Let's say we have f of x equals the square root of 9 minus x squared. So, if we are looking at a radical function or square root function, we first identify its domain. And we know that the domain of a square root function is the set of all real numbers that will not make the set of values of x that will not make the radicand or the expression inside the radical signs negative. So we can test for this, we have 9 minus x squared dapat greater than or equal to 0 siya. Okay, so that's negative x squared greater than or equal to negative 9. We divide both sides by negative. Then we change the inequality because we divide by negative, so 9. Extract the square root. So that's plus minus square root of 9. And that is plus minus 3. Okay, there is a test here whether to use the other, what inequality symbol will be used for positive 3 and for negative 3. Okay, we check. Let's say if x is greater than or equal to 3. So we test, let's say x is equal to 0 because this is less than or equal, rather this is less than, sorry. So x less than or equal to 3, so x is equal to 0 because this is less than 3. We check 9 minus 0 squared, so meron 9, so pwede yung less than 3. Okay, so if it is greater than 3, so 4 squared, so let's say 4, 9 minus 16 negative, so wala. So we use less than or equal to positive 3. How about yung negative 3? Let's say we use greater than or equal naman. So what is the what value we can use? Greater than or equal to negative 3. Let's say negative 1 because negative 1 is greater than negative 3. So negative 1 squared, positive 1. So 9 minus 1, 8. So there's a square root. Okay? So there is the domain would be this one, the combination of this. And if we write it, looks like this one, greater than or equal to negative 3 but less than or equal to 3. Okay? So in interval notation, its domain is from negative 3 to 3. Okay? Take note that if we have this form, to simplify the discussion, if we have this form, let's say a constant squared minus x squared, its domain is always what? From negative a to a. What is a? A is the square root of a squared. In this case, we have 9. The square root of 9 is 3. So the domain is from negative 3 to 3. Okay. So all the intervals that belong to this domain, continuous yung function. So say for example, so in this case, ang domain niya is negative 3 to 3. Sa aning interval, let's say, na continuous yung function. Let's say, negative 3, 3. Open interval, negative 3, 3. So, negative 3, 3 belong to this one. Okay? This is inside the domain. So, continuous siya. Let's say, 2, 3. The half open interval, we have 2, 3. 2 is between negative 3, 3. Then 3 is also the part of the interval because we have close. So, still continuous siya. About negative 1. Okay. About negative 1, 1. So, negative 1, 1 is still between negative 3, 3, right? It is inside the domain. So, still continuous siya. So, that's the possible intervals for which the function is continuous. So, for all intervals that belong to the domain, continuous yung function. Mag-try tayo ng mga sample interval na discontinuous yung function. Let's say we have negative infinity to 3 to negative 3. Okay, negative infinity to negative 3. Negative 3 is included, so pwede. But, sabi sa left endpoint, negative infinity. So, this means it can be negative 4, negative 5, negative 6, etc. But that's, they are not belong to that domain, right? So, that's why discontinuous siya. At this interval. Say we have 4 to 10, a closed interval. So 4 to 10 is outside the given domain. So discontinuous siya. What else? Let's say we have mm, so positive 3 to positive infinity. Okay, included si 3, okay, but 4, 5, 6, 7 is outside the domain, so that's why discontinuous siya. Okay? So that's how to check whether the given interval is discontinuous or continuous at the function like this one. Let's have the last one. Let's say we have f of x equals x squared minus 9. Okay, for this one naman, parang reverse siya nung example earlier. So, ang domain naman niya is outside of plus minus 3. That is from negative infinity to negative 3. Pero we include negative 3 because defined pa rin yung function at negative 3 in union with positive 3 to positive infinity. Okay? So, ang technique lang for all function in the form x squared minus a squared, its domain is in the form negative infinity to negative a in union with a to positive infinity, where a is the square root of a squared. That's true to all. Okay? So, continuous yung function if the given interval belong to this domain. Okay? Say for example, na mga continuous. Let's say we have negative 10 to negative 3. Okay. So, negative 10 to negative 3 belong to this one, right? So, that is why the given function is continuous to this. Let's say we have 4 to 8. So, 4 to 8 belong to this one. Kasi 3, 4, 5, 6, 7, and so on. So, still continuous yung function. Let's say we have, let's say 3 to 4. Okay? Is the function continuous? Yes. Because 3 to 4 belong to this interval. Okay? So, continuous siya on these intervals. Ano yung mga discontinuity? So, syempre yung outside. So, kumbaga, yung lahat ng intervals in which the function, in which they are what? Outside of this. So, this one, so, kumbaga, mayroong mga set of numbers dito sa part na to. Lahat ng nandito, discontinuous siya. Say, for example, negative 1, 1. Negative 1 is to the right of negative 3, but it is to the left of positive 3. So, discontinuous siya dyan. Okay? Let's say, negative 2, 3. Okay. Although, okay yung 3, but yung numbers to the right of 3, like negative 2, negative 1, 0, 1, 2, and the decimals and fractions between them, hindi continuous yung function, hindi defined. So, still, discontinuous siya dyan. Let's say we have, ano pa ba? Pwede naman kunwari. Let's say, negative 4 to 4. Is the function continuous here? Okay sa negative 4, okay sa positive 4, but the numbers between them are not okay, right? Because we have negative 3, negative 2, 0, 1, 2, 3, 4, and the numbers between them also. So, hindi define yung function. So, kaya siya discontinuous at this interval. Okay? So, that's all for the continuity on an interval. Say, for example, last one, if you have the function, let's say f of x equals square root of x plus 1. So just make it x plus 1 greater than or equal to 0 then x greater than or equal to negative 1. So the interval for this, for the domain, is just from negative 1 is greater than or equal to positive infinity. So all the numbers or interval that included here in this domain, continuous yung function. But if the interval is outside the domain, so then that function is discontinuous. Okay, so I hope you learned about something on continuity on an interval.